Many people travel from around the world and from across Canada to climb and visit Mount Robson, which is the tallest mountain in the Canadian Rockies. Mount Robson is located in Mount Robson Provincial Park in British Columbia. It has an elevation of 3,954 meters according to BC Parks. This is quite high and is equivalent to nearly 13,000 feet. Some people may begin to feel the effects of altitude sickness at these heights. If you're planning to summit Mount Robson, it may be helpful to have a brief overview of the causes, symptoms, and treatments of altitude sickness. Most people know that our blood is responsible for carrying oxygen throughout our bodies, but how does this occur? The answer is hemoglobin. Hemoglobin makes up a large portion of our red blood cells. Hemoglobin is composed of 4 heme groups surrounding a globin group, forming a tetrahedral structure, according to Britannica 2018. Each heme group has an iron atom attached to it. It is the iron that is able to bond to the oxygen and transport it throughout the body. Since there are 4 heme groups and 4 atoms, each molecule of hemoglobin can carry 4 oxygen atoms. The hemoglobin forms a weak and reversible bond with the oxygen that allows it to be transported throughout the body, almost like a person getting on and off of the train. Once the hemoglobin has the oxygen atom, it is referred to as oxyhemoglobin, according to Britannica 2018. The reaction of the hemoglobin and the oxygen creates oxyhemoglobin and forms an equilibrium within our body. This represents the hemoglobin-oxygen equilibrium. How does all of this relate to people wanting to climb Mount Robson? This equilibrium and the shift that results from the increase in altitude are what cause the effects of altitude sickness. This can all be explained by Le Chatelier's principle. It states that if a dynamic equilibrium is disturbed by changing the conditions, the position of the equilibrium moves to counteract the change. Disturbances can be a change in temperature, change in concentration, or a change in pressure/volume that may cause the equilibrium to shift. When climbing a mountain, it is the change in pressure/volume that we are most concerned about. As the elevation increases, the air pressure decreases. This decrease in pressure is what causes the equilibrium to shift. When the pressure decreases, the equilibrium will shift to try and increase the pressure. To do this, the equilibrium shifts towards the side with more gas molecules. It is the gas that is responsible for creating the pressure. In this case, it is only oxygen on the left side, so the equilibrium shifts left. By doing so, less of the oxyhemoglobin is produced and more of the hemoglobin and oxygen are produced in an attempt to try and increase the pressure of the system. As a result of this shift, you are now short of oxyhemoglobin. This is what causes the altitude sickness associated with high altitudes. Since you are now producing less oxyhemoglobin, your tissues and body are no longer getting enough oxygen. Altitude sickness can be very mild or it can be life-threatening, depending on how extreme the change in altitude is. In the case of Mount Robson, the effects would most likely not be life-threatening. Some symptoms may include headaches, loss of appetite, nausea and vomiting, feeling weak, with no energy, poor sleep, and feeling dizzy, according to Altitude Sickness 2017. To help with the symptoms, the best thing to do is to go to a lower altitude. This way, the equilibrium will return to its normal state. If you only have mild symptoms, it is wise to rest and drink lots of water while your body adjusts to the new equilibrium. Medicine may be taken to help with the headaches or nausea associated with altitude sickness. Oxygen tanks may also be used. This is very common among climbers at high altitudes. Using the oxygen increases the concentration of oxygen that you're receiving. Again, we can use Le Chatelier's principle to see how this affects equilibrium. When the concentration of the reactants increases, the equilibrium will shift to increase the concentration of the products. That means that more oxyhemoglobin will be produced. With more oxyhemoglobin, your body is now getting the necessary oxygen to function properly, and the effects of the altitude sickness will go away. In understanding how hemoglobin functions and the effects that increased altitude have on your hemoglobin-oxygen equilibrium, hopefully you can use this knowledge to help you avoid altitude sickness on your climb.